Hi everyone, we're going to be looking at the next form of factorization today, but before we do that, we're going to just review very quickly what we've done so far. So the steps that we want to take when we are factorizing is we're going to have the expression that needs to be factorized, and the first thing we want to do is always check to see if there is a common factor to remove. So that would be what we did in the last couple of days, which was, for example, if you have 3x plus 6, when we factorize that, we are removing the common factor, which is 3, and what's left over inside the parentheses is x plus 2. Now, the second form of factorization that we looked at was the one where we say, okay, we've got 4 terms in there, not 3 or 2, but we've got 4 terms, and there doesn't seem to be anything that can be removed from all 4 terms. Therefore, what we do is we group. So we take the 4 terms and we do grouping in pairs. So for example, the example I gave here was 2x squared plus 6x plus 3x plus 9. So if I cut this in half, or if I put like a little imaginary line in between, it's like as if we had 2x squared plus 6x on its own and 3x plus 9 on its own. And we can see that the common factor to remove from the first half is a 2x, and what's left over is an x plus 3. And what's common to remove in the second half is a 3, and what we're left with is an x plus 3. Now, because these two parentheses are equal, and they should always be equal in this case, then I can remove an x plus 3, and what's left over is going to be a 2x plus 3. And that would be my final answer. Now, what we're going to be looking at today is we're going to be looking at difference of squares, the difference of two squares factorization, and perfect square factorization. All right, so let's get started. All right, so when we're looking at, in section 8b, the difference of square factorization, now we need to remember what a difference of squares is. So if you recall, when we were expanding a plus b times a minus b, which is right here, so when we were expanding this, what ended up happening was that we got a squared minus b squared. The middle ab term disappeared, so that a squared minus b squared brings us to a plus b times a minus b. We're going backwards this time. So if we are expanding, we go from a plus b times a minus b to a squared minus b squared. And if I'm going to factorize, well, I should recognize in the factorization process, I should recognize that because I have only 2 terms, and they're both squared terms or factors, or that they are perfect squares, then I know that I can take the square root of both a and b. So for example, if we had factor x squared minus 9, well, the question that you're going to be asking yourself is, what times itself gives x squared? And then you'll ask yourself, what times itself gives you 9? So that if I take the square root of x squared, that'll give me x. And if I take the square root of 9, that gives me 3. So since both of them are perfect squares, and there's subtraction going on between the 2 squares because it's a difference of squares, then what we end up having is, putting them back in the parentheses, we're going to have x, and it'll be x minus 3 and x plus 3, or x plus 3, x minus 3. It's irrelevant, doesn't matter. So if we look at the next example, we've got 4x squared minus 25. All I need to do is take the square root of the first, which is 2x, and I take the square root of the last, which is 5, and then one of them has to be negative, and the other one has to be positive. Because remember, we said that the difference of squares only ends up with two terms in it. We get rid of the middle the middle x term. So we're left with the x squared, we're left with the constant, but the middle x term disappears. Okay, let's take a look at some other examples. So if I have 4y squared minus 36y to the 6th, then what I can do here is, again, I can remove a common factor first, because 4, remember, that's always those are the steps that you want to be taking. First you check to see if you can remove a common factor. Then you check to see how many terms there are. If there's 4, well, chances are you're going to have to split it into 2 groups of 2. And if there's neither of those, then the next thing you would check for would be the difference of squares. So when I take a look at this, it appears that I can remove a common factor first. So the common factor in this case that I can remove is actually a 4. So if I remove a 4, what's left over? Actually, I can remove a 4y squared. I can remove a 4y squared, and what's left over is a 1 minus 6y to the 4th. Okay. Now, 4y squared can't be simplified any further, but 1 minus 6, 1 minus 9, y to the 4th. So what you notice is that I can take the square root of 1, and I can take the square root of 9, which is 3, and the square root of y to the 4th is y squared. So that means that I have a difference of squares here. I've got 2 terms, which both of them are perfect squares, and therefore it becomes 1 minus 3y squared, 1 plus 3y squared. Let's take a look at the next example. We have 5 bracket n squared minus 20. So if I remove the 5, I'm left with n squared minus 4. So this gives me 5 bracket, the square root of n squared is n, the square root of 4 is 2, so it's going to be n minus 2, n plus 2. There is no middle n term. And if I end up with, for example, in the next question, I've got t cubed minus 16t, I can certainly remove a t, and what's left over is a t squared minus 16. And then on the inside bracket, I actually end up having t bracket, and then it'll be the square root of t squared is t, the square root of 16 is 4, so it'll be t minus 4, t plus 4. And the last one, I've got x squared plus 16. Well, technically I can take the square root of the first, and I can take the square root of the last, but what I should have in the middle here is a negative, not a positive. So I shouldn't have plus 16, but I should have minus 16 in order for it to be a difference of squares. Therefore, this would not be considered possible, so it would be not possible for factorization. Okay, let's do very quickly just a couple more. So 4x squared minus 16y squared would take me to 2x, would take me to 2x minus 4y, and 2x plus 4y. 9a squared minus 25 will take me to 3a minus 5, 3a plus 5, and 64y to the 4th minus 16x squared takes me to 8y squared minus 4x, and 8y squared plus 4x, because there is no middle xy term. Alright, now the questions can get a bit more complicated. So for example, I could have x minus 3 all squared minus 16. Now, I may not recognize this as being a difference of squares, but if I were to let a equal x minus 3, okay, then I would replace that a for x minus 3, and I would end up with a squared minus 16. Now, because a squared minus 16 is definitely a difference of squares, then I know that it's going to become a minus 4 times a plus 4. But because a is going to now be replaced again by x minus 3, it means that I will have x minus 3 minus 4 and x minus 3 plus 4. So So my final answer would go to x minus 7 times x plus 1. All right, again, you don't have to do it in the first method where you substitute the a's. You might be able to just recognize it, as in the next example. I see it and I say, well, it's x minus 1 minus p and x minus 1 plus p, and I'm done. So if we do just a couple of other examples, I'll just randomly pick a couple. Let's do question D here. So we've got 16x squared plus 64y squared. Well, it appears that you could take the square root of everything because everything is a perfect square here. The only issue is that I've got a plus. And because I have a plus, this is going to be a no solution or not possible. Okay, let's take a look at the next one at E. We've got 36m to the 6th minus 49n to the 6th. So because we have two terms, we have a minus in the middle, and I can take the square root of everything here. Then this would go to 6m minus 7n times 6m plus 7n. And the last one, let's just do one more. A squared minus 16b squared, well, that will go to a minus 4b times a plus 4b. Now, the only other thing that I'd like to go over very quickly is the perfect square factorization. It isn't absolutely necessary to learn the perfect square factorization, but so with perfect square expansion, or factorization rather, now if we look at the expansion of perfect squares, then we would see that we would square the first, we would square the last, and then we take 2 times the product of the terms in the brackets. That's how we expanded these. Now, if we were to do the opposite, okay, so let's try to factorize. All right, so we're going to try to factorize this question, and we're going to try to recognize it as being a perfect square expansion. So, factorization. So since in expansion we square the first and we square the last, and then we do 2 times the product of what's in the binomial, then if I were to take the square of the first, so I've got x squared plus 6x plus 9. If I were to take the square of the first, that would be x. And if I were to take the square of the last, well, that would be 3. Now, if I were to combine these two together, it would be 3 times x is 3x, and then it would get multiplied by 2 and would give me plus 6x. Therefore, the answer is correct. So it would have to be x plus 3 times x plus 3. That would be my solution, or x plus 3 all squared. Okay, again, I'm going to do one more example, and then I will expand a little bit more on this in class. So I take a look at my quadratic trinomial here. I've got 1, 2, 3 terms. And the first thing I normally would do is I would check to see if there are any common factors to remove. There aren't any. This is definitely not a difference of squares. So therefore I would try the next one, which is perfect squares. I would take the square root of the first. I would take the square root of the last. Now if I actually multiplied these two together, x times 5, that would give me 5x. But if I multiplied it by 2, it would go to 10x, which would give me my middle term. So my answer is going to be x minus 5 times x minus 5. So there is my perfect square. X minus 5 all squared. All right, thank you. I'll see you next time.